So let's try to determine whether this series is convergent or divergent. And for that, we're going to use comparison test. So I want to compare this series with the one that I know is convergent or divergent. So I'm going to start like that. I'm going to take the general term of that series, and I'll think what I can compare it with. So when I'm comparing general term to something, I want to make sure that either numerator stays the same or denominator stays the same. Well, since numerator is constant here, it makes sense to keep the numerator the same, 1. But in the denominator, I'm going to just put square root of n. Now, one reason I'm just putting square root of n is because, first of all, now I can compare the denominators and overall expressions. And second, this creates a general term for a p-series, right? So when I write this down like that, I'm thinking about p-series. Like that. 1 over square root of n, but that is the same as 1 over n to the power 1/2. So p equals 1/2. Since that power is less than or equal to 1, it means that this series is divergent. So this series is divergent. But let's see if we can use it to actually say something about our series. So for that, we need to determine the sign to put in between them. How do they compare? Let's think. Numerators are the same. What can we say about the denominators? Well, this denominator is smaller, right, than this one over here. Well, it's 1 less. So this is smaller denominator. And since this denominator is smaller, it means that overall quantity is bigger, right? So we'll have to use greater sign. Okay, so when we use greater sign, and that means that terms of this p-series are smaller than terms of our series. Now, can we make any conclusions about our series based on the comparison test? Yes, we can. When the series with smaller terms diverges, then series with the larger terms should diverge as well. So that means that our series is divergent by the comparison test. Let's try one more example. Same question, we need to determine whether the series is convergent or divergent. And we're going to try to apply comparison test again. So I'm going to start by thinking to what I can compare. This general term, 1 over cube root of 3n to the 4th power plus 1. Right here. Since the numerator here is the constant, it would be great to compare it to something that has that same constant in the numerator. But then I will adjust the denominator. So what I'll do, I will remove that 1, because as I remove that 1, it's going to be easier for me to compare the denominators. I'll just leave cube root of 3n to the 4th power. So how can I compare them? What can I say about those two? Well, numerators are the same. Now, the first denominator is larger, right? So it's a bigger denominator. And since I'm dividing same quantity by something bigger, it makes the first fraction smaller compared to the second one. So I have to use less sign. Now, let's see if that new expression that I created defines the series for which I know whether it's convergent or divergent. So this is how the series would look like. Series from 1 to infinity of 1 over cube root of 3n to the 4th power. And of course I know that the constant can be put in the front of the series and it will not affect its convergence or divergence. So what I'll do, I'll place 1 over cube root of 3 in the front of the sigma sign. And then I'll have, what will I have here? I will have 1 over, so it's going to be cube root of n to the 4th power. And now it looks like a p-series, right? It's n raised to a certain power. What is that power? Well, it looks like the power is 4/3. So yeah, that's a p-series, and for that I'll know whether it's convergent or divergent. P equals 4/3, and that is greater than 1. Since it's greater than 1, it means that this series converges. It converges. But is this helpful for our comparison test? What I know is the series that has larger terms, right? That's the one that has larger terms. Series that has larger terms converges, so it has a finite sum, in other words. And if series with larger terms converges or has a finite sum, it's definitely that series that has smaller terms. If I add up smaller terms, that they should also add up to a finite sum. So yeah, in this case, we can use the comparison test. Everything works out right for the comparison test, and we'll make conclusion that this series is, well, it's convergent, as we said. By the comparison test. Always say what test you've used.